Hello dear students, in this video we are going to discuss about the next bottom-up parser, that is CLR1 and LALR. So in the previous videos we have discussed other bottom-up parser like ELR of 0 and the SLR of 1. And the other two algorithms we are going to discuss here is CLR and LALR. What does CLR means? It is a canonical LR of one look ahead, and LALR means look ahead LR of 1, and the most powerful bottom up parser is CLR1. And this is also similar to the other algorithm we have discussed in SLR. In addition to that, in every item, we are going to attach a look ahead. So that is what the difference we have with CLR. So how to find a look ahead is, let us take an example. Let us first let me let you know the rule to find the look ahead to be attached with each and every item. You know what is an item? To a production, when we attach a dot to it, it will be called an item. Let us consider there is a production A derives alpha dot B beta comma A. If this is so, so here you can see this is a look ahead attached to an item. So item means you have a dot in the LRHS. And so you know that after the dot, if you see here, there is a dot, no? So after the dot, there is a non-terminal. What will we do? We will write the closure of it, and we'll write the corresponding production of B, start with a dot like that. And then along with that, you have to attach the look ahead here. That is the difference. So how will you find the look ahead of it is, you have to find first of, and you have to, now we are writing the closure of B, right? So you have to write the rest of the symbols available after that. So here it is beta A. So here, what is the first of, so rest of all you are writing. So here you have beta, and here you have A. So what is first of beta? First of beta A is beta. So this is how. So you have the productions, comma, and this is what the look ahead attached to the closure of B. So this is the rule. So you have a production. After the dot, you have a non-terminal. So you will write the production of the closure of B, and then you have to attach a look ahead by separating it with a comma. In that case, you have to find the first of remaining all the symbols available there. So let us start. So this is the only additional thing we are going to do with that. So first we are going to discuss on CLR. After doing the CLR of 1, then we can continue that with the LALR. So if you know CLR, you can easily learn LALR as well. So as usual, the first thing you have to do is, you have to introduce a new production. So here, what is the starting symbol here is yes. So you will be bringing that start symbol to the RHS, and then you are going to introduce a new symbol S dash. And here this is what, and here as I told you, you have to attach a look ahead. So initially we are going to start it with a dollar, and you have to make a dot here to make it as an item, right? So now let us find all the canonical item of it. So always the canonical item set will be starting with the augmented production S derived dot S, and then you have to attach a look ahead. So in the beginning, we are going to start with the dollar. Okay, so and now you can see after the dot, there is capital S, that is a non-terminal. So you have to write the closure of it. So S derives dot, you have to write the production of S. So you have only one production of S. So dot A is written. And then after that, you have to attach the look ahead as we saw in this rule. So, you know, for yes, we have written the closure. So the rest of all here you have nothing. And here you have dollar. So first of dollar is dollar itself. Okay, and now this is how. So remember this rule. So after the B, what are all there? You have to write the first stuff. So here after yes, what are all there? Only dollar is there. So we wrote it. Now you see after the rest of all is similar to SLR. Now you see after the dot there is a non-terminal. So if we have a non-terminal, what will you do? We will be writing the productions of A. So A have two things, dot A, and then next one is A derives dot B. So these are the two closure of this A. And now you have to find the look ahead. So how will you find the look ahead? See here. for this A only, we wrote this two closures. So first A. So what did you do? So to find the look ahead after that, you have to find first of capital A and dollar, right? So you have to find first of A here. Who is in the first? A. So A means A is a non-terminal, so we cannot directly write. So you have to find first of A. And who in this is the production of A. A derives A and A derives B. So who is the first of this? A or B. So the first of A, we have two symbols, A as well as B. So here we have to write A or B. Got it? So this is how we have to find it. And the look ahead of this both production is A or B, because this two production came from this production, this place. So for both you have the same look ahead. Hope you have got it, right? And now if you see after the dot there is a terminal, after the dot there is a terminal, that's it. So we completed the first canonical item set I0. So this is I0. So as usual, so only thing we have attached here is the look ahead. So we are going to call it as I0 canonical item set. So now you can see who is the next symbol to read. Yes. So when I read S dash derive S dot and write as it is, because we are going go to, right? In go to nothing will be there, and after the dot nothing is there to do the closure, and here also no other S to read. So that's it. This is the only item available in the next state, that is canonical item set of 1. Then who is the next thing to read here is capital A. So when I read capital A, it is right, yes, derives A dot A. The dot will go to the next place and write the dollar as it is. Since it is coming from in the go to, write as it is. And here there is no capital A to read, so that's it. And now you have to look at here. After the dot, you have a non-terminal. So that is the capital A. So you have to write all those productions of A. So A derives dot small a capital A and A derives dot B. And now you have to see the closure of it. Look ahead of it. How will you find the look ahead of this two? So already I have taught you after the dot, we are finding the closure of this capital A. So you have to find the first of the rest of the symbols here. So here nothing is there. Here you have dollar. So first of dollar is dollar alone. So here I have to attach a dollar. Here also I have to attach a dollar. That's it. And now if you see after the dot here, terminal, here also a terminal. So no more items to be added. So that's it. So this is the next canonical item set that we call it as I2. And if you see here, what is the next thing to read is small a. So when I read small a, what will happen? A derives A and the dot will come to the next place and write the look ahead as such. And now if you see after the dot, there is a non-terminal. So write all the productions of A. So start as an item, put a dot there and dot B. Now the next thing is what you have to do. Now you have to see. So this two items came from this. This is the closure of this. So now you have to find the first from this to write the look ahead. So how will you find? You for this A only you're finding. So the rest of all we have to find the first of. So what is first of A or B? A or B only. So we are going to write the same thing here. So the same thing. So now after the dot, there is terminal. Here is also terminal. So no more further items. So that's it. So this is item I3, canonical item set. And the next thing to read is, we have to read B. When I read B, it is A derive B dot and write the look ahead as said. When you go to, don't do any other, apply any rules, just write as it is. So now we have completed. So in this canonical item 0, we have read all the symbols. Yes, A, small b, everything is done, right? That's it. So now let us go to the next item. So canonical item 1, here nothing is there to read. So that's it. Now here, what is the next thing to read here is capital A. So when I read capital A, it is S derives A dot and write the dollar asset. And then there is nothing to do. Here is also no other capital A to read. So we will finish this item. We will number this item. This is I4. And now this is I5. Okay. So this is over. Now, what is the next thing we have to do here is small a. So when I read small a, it is like a derived a dot, and the a dot will come here and the dollar. Now, if you see after the dot, there is a capital A, that is a non-terminal. So write all the predictions of A. A derives dot B. And now we have to find the look ahead of it. So for this A only, we are finding this two closure. So for the rest of the symbols, you have to find the look ahead. So here we have only dollar. So first of dollar is dollar itself. So I'll write dollar here. And after the dot, here is a terminal. Here is also terminal. So no more further uh, expansion. So we'll finish this canonical item. This is I6. So in I2 only we are doing all this. What is the next symbol to read here is B. So let us read B. So when I read B here, it is like A derives B dot and the look ahead is dollar. So what is there? So when you do go to write what is there as such. So don't apply any rules. So that's it. So this is that. Now come to I3. So what is the next thing to read in I3? We have to read A. So when I read this capital A from I3, what does it become? So we are reading no. So A derives A capital A. The dot will come to the next place because A is read and write the look ahead as such. So here no other A capital A is there to read. Here also no other closure to done. So this is completed and this is I7 and this is I8. And now, what is the next symbol to read is small a. So when I read the small a, I will get the same state again. For you to understand, I'll write one time. Okay. So when I read the small a, what will become? A derives a dot a and write the look ahead as such. So dot after the dot, there is a non-terminal. So I'll write all the productions of a dot capital A and dot small b. And so for this A only we wrote this closure. So the rest of the thing you have to find first. So there is ARB. So ARB is first is ARB itself. First of A is A, first of B is B itself. So now if you look this one and this one, both are same, right? So you don't want to repeat it again. So instead of writing all the productions again, what will I do is I'll just say when I read on A, I'm going to get the same I3. So now you can see here I have to read a capital A, that is done. Then I have to read small a, that is also done. And when I read small b, I will again get the already completed production. This is what I'll get again, right? So I'll write it as I4. So this state's name is I4. So that is what we are getting again. So this is over. I3 is over. So now what is I5? So I5, everything is done already. Now in I6, you have to read what? The next thing to ready to read is capital A. So when I read it, it is like A, capital A dot, and write the look ahead asset. So this is completed. So this we can call it as I9. And the next thing here to read is small a. So when I read the small a, I'll get the same state again. So I will say when I read small a, I will get again I6. And here when I read small b, I will get I7 itself. Right? I'll get the same thing as I7. So I don't want to write again. I just write the state number. And now this is over. I6 state is over. Then I7, nothing is to read with I7. And for I8 also, nothing is to there to read. So we have completed all the things. Okay. So that's it. So we have found all the canonical items. So we have the states from 0 to 9. That's it. Now we are going to do so these are the procedures for CLR. So we'll first complete CLR. Okay. So now the next thing we have to do here is we have to find the parsing table. So how you do the parsing table for SLR? Same thing only here as well. So you have to write all the states in the row 0, 1, 2, 3, 4, 5, 6, 7, 8, and we have 9. So totally 9 states are there. And then the first part here we have what action part, and the next part we have is go to. So in the action part we will be writing all the terminals. So what are the terminals here? We have in the context-free grammar, if you check, we have A and B. So don't forget to add the dollar. So the next part we have in the column is go to. So in the go to, we have to all the terminals, that is S and capital A. So if you see your context-free grammar, that is what terminals are, small a and small b. Along with that, you have to add the dollar. We have added, and then non-terminals are S and E. So we have written both. Now we are going to start filling this table. So from the zeroth state, you have to look at in the zeroth state, what are the go-tos we have? On capital S, it is going to 1. So write here the number alone. And on capital A, it is going to 2. So write in go to, just write the number. Hope you remember the previous algorithms. And then small a. On small a, it is going to I3. So if it is this side, you have to write S3. The 3 is the state number, and you have to write a shift. And then on small b, it is going to I4. So I have to write S4. Got it? So that's it. So we're done with the state number 0. And now we go to state number 1. If it is state number 1, if you look at here, it is a final state because we have read all the symbols, and that too, it's a special production. That is the augmented production. No? So already as we have learned in SLR, if it is an augmented production and that too it is a final state, then you have to write 1 on dollar. See here, 1 on dollar, we have to write accept. So 1 on dollar, you have to write accept. And in the state number 1, we don't have any other go to, so that's it. Then we have to go to the next state, that is second state. If you see in the second state, what are the go tos we have? We don't have any final state. We have go to on A. On A, it is going to I5. So you have to write the number alone. And then from this, on small a, it is going to I6. So write S6 here. And then on small b, where it is going, on small b, it is going to the state called I7. So I'll write S7. Shift 7. 7 is the state number. Since it is a terminal here, we'll write as shift S7. So that's it. And then go to the next state, that is third state. Okay, go on to third state. Where is the third state? Here. Here is the third state. For the third state, we have what are the go-tos? One is capital A. On capital A, it is going to I8. So on capital A, write 8 alone. And on small a, it is going to I3. So on small a, you have to write S3. On small b, it is going to I4. It is S4 then. And then go to the next state, that is the fourth state. When you read the fourth state, it is a final state. So what will you do? So you have to, again, don't forget to number your production. This is the first production, second production, third production. And now this is a final state. Find the production number. A derives B is the third one. So third production. So in A, now there, if you remember in SLR, we will be finding in the follow position. For the follow position, we'll write the reduce. But here you just look at the look ahead, and in the place of look ahead alone, you write those reduction. So in the place of A and B, you have to write R3. R3. Since it's the final state, write R3. What is 3? 3 is the production number. And since it is a final state, we are going to reduce it. So we have to write R. And this is in the fourth state. So in the fourth place, why you wrote here A and B is the look ahead. So in the place of A and in the place of B, we wrote R3. So that's it. Now we are going to the next state called I5. So what is there in the I5? I5 is again a final state. So what is the number of it? Yes, there is A is the first production number. So in the place, see the look ahead. In the look ahead, we have only dollar. So in the place of dollar, we have to write this R1. So in the place of dollar, write R1. That's it. There is only one production, and that is a final state. So we're done with that. And the next one is sixth state. So if you see in the sixth state, we have on 3 go-tos are there. On capital A, it is going to 9. So on capital A, it is going to 9. On small a, it is going to I6. Small b, it is going to I7. So here you have to write S6 and S7. Okay. And the next state is I7. And if you see the I7 state, it is a final state. What is the production number? A derives B is third production number. And in the place of, you see the look ahead, in the place of look ahead, there is a dollar. So in the place of dollar, we have to write R3. So here you have to write R3. So that's it. Now there is the final state and it is no other go-to is there. And now if you see I8, it is also final state. What is the production number for it? It is second production number. So what you have to do in the place, look ahead, you have A and B. So in the place of A as well as in the B, you have to write R2 since it is a final state. So in A and in the B, you have to write R. So finally, the lines are slanting. So sorry for it. Now you have I9. In the I9 is also a final state. And what is the production number for that is seconds. This production is only available here, right? So this one. So in the place of dollar, see here in the look ahead we have dollar. You have to write as R2. So in the place of dollar, so if you see here, in the place of dollar you have to write R. So the parsing table is over. So this is how we have to make the parsing table for CLR. So this is very easy, right? So along with that, we are going to learn the LALR also. So if you do the CLR, you can also do LALR. What is the difference in LALR than the next algorithm of bottom-up parser is? See, if you look at here, what to say? You look at this two states. What are its two states? This state number 4, I4, and if you see the state number 7, you see this both, this fourth I4 and I7. Both are same, but what is only changing? This look ahead is alone changing, right? So what we are going to do is, we are going to merge this two state. So I'm going to write a new state, I4, 7. And the state is A derives B dot. There is no change in it, but only look ahead is changing. So I'll say A, B, and I'm going to merge all the look aheads. So here in the state number I4, the look ahead is A or B. And if you see in the look ahead of I7, the look ahead is dollar. So I merged A, B, and dollar. So this is what we do in a LALR. And similarly, you see other states as well. What other state you can see? You see this 3 and 6. If you see the state number I3 and I6, both are same, but only look ahead is changing. So we can even merge that as well. So I can write I36. So what are the productions? A derive A dot A, and I'm going to merge this two. So all the three look aheads, and A derives dot A and A R B are dollar. So I'm merging the look ahead, and dot B here A R B are dollar. So I merged this third state as well as the sixth state, and I got a new state called I36. Okay. And now, is there is any other? Yeah, you look at this 8 and 9. If you look at this 8 and 9 as well, you can see the productions are same, but only look ahead is changing. So we'll merge that as well, 8, 9. So if you merge, the production is A dot A and merge the look ahead. So I'll get again a new state called I8, 9. So in LALR, hereafter there is no state called 4 separately. We have 4, 7 together. We have 3 and 6 together. 8 and 9 together. So we have merged this since only the look ahead is changing. So how will the parsing table will change? Let's look on it. So let me shrink it for you to keep it ahead. So now we are going to write the LALR's parsing table. Okay, so from this parsing table, you can derive that as well. So here first, as usual, we have to write all the states. 0 state is there, 1 state is there, 2 state is there, but 3 state is now merged to 3, 6. And 4th state is merged to 4, 7. And 5 is there, 6 is merged to 3, and 7 is also merged to 4, and 8 is merged to 9. So only this many states are there. And now here again we have action as well as we have go to. And in the action, we'll write the terminals A, B, and dollar. And here we will write all the non-terminals. So as usual, we have to write and we can merge it together. Okay. So now if you see here, let us write for the zeroth state first. So in the zeroth state, we have S3. But there is no state called S3, right? So it is S36. And for this one, we have S47. And here it is 1 and here it is 2. So then in the first state, accept alone is there. As such, you are writing. And in the second state, what are there in the second state? S6 and S7. So S6 is now merged with 3 and S7 is merged with 7. Got it? And here 5 as such. There is no change in the 5. And now if you see 3 and 6. So 3 and 6 are merged together. In 3, if you see here, this 2 are we are going to merge 3 and 6. So when you merge this 3 and 6 will be merged together and we'll get 3, 6. And here if you see 4 and 7, we are merging 3 and 6. So as usual, we are correctly getting it as yes, 4, 7. And now here it is 9, 9, and you can see here you have 8 and here you have 9. So 8 and 9 is already merged. It's automatically coming in same way, right? Okay. And then if you see 4 and 7, look at this 4 and 7. This is 4, this is 4, and this is 7. Here nothing is there, but here we have R3. So we have to write R3, R3, and in the 7th state you have another R3. So that is also written. See, this 3 is not should not be written as 3, 6 because this 3 came from the production number. But this 3 and 6 came from the state number. So we merged those two states. So we written as 3, 6. But in reduction, if you see here, here is R3, here nothing. So when you merge, this is written. So R3 is the production number. So don't write as 3, 6. Just write 3 because it's a production number. And now here, no, nothing else in the go-to part. And similarly, and fifth state, if you see in the fifth state, what is there? Here is only R1 and nothing is there. And 8, 9. So the state number 8 and 9 need to be merged. So what we can do here, it is merge R2, R2, R2. Got it? So that's it. So now we got the parsing table for the LALR. So what is the difference between CLR and LALR? In LALR, we are going to merge the production or the items, canonical item set, which is only differing by its lookahead. Those states are merged together. And since it is merged together, we can also merge the parsing table as well. And then when you do any of the parsing table is done. So let us check with parsing as well. So let us find the input string for it. So S derives A. Let us do a simple one. And then it is A can be written as A and small a as such, and this BB. So this is a string which can be derived from this string. So let us do a parsing as well so that you will be clear till the parsing. So let us now do the parsing. So what are the things required here? We need a stack and we need a symbol as we did in the SLR, and then we need an input string. So the input string we derived here, we got as ABB. So we are going to try to do with ABB and end it with a dollar. And what is the action we are going to do here? And now the stack will be starting from the zeroth state. Okay, so now let's start doing. Okay, so now what you have to do, you can use ACLR or LALR. Now let us use this parsing table of CLR itself and we will do. So CLR is the most powerful parsing. Okay, that also you have to remember. Now you have to say 0 on A. What is 0 on A? It is S3. So 0 on A is S3. Remember here you have dollar. So S3 means shift, right? So here the pointer is there. So when you shift, A will be coming here and you have to push this here. So it is 0, 3. Push here. So when it is coming here, so dollar A is pushed here. So here it is BB dollar. So now the next one is 3 on B. So what is 3 on B? Look at here. What is 3 on B is S4. So again a shift is there. So what will you do? Dollar A, and the B will also be coming. Here it is B dollar. And then this 4 will be pushed inside the stack. Now it is 4 on B. What is 4 on small b? 4 on small b is R3. So it is R3. So what is the R3 production? A derives B. So right, we have to do a reduction. So which means here B can be now reduced to capital A. And what is the next thing? Since in the RHS we have only one symbol, reduce one here, and then you have to say 3 on capital A. So 3 on capital A. Same thing as in SLR. So 3 on capital A is 8. So you have to write 0, 3, 8. And here it is B dollar itself. Now what is the next thing? Top of the stack we have 8, and here it is B. So 8 on B. So 8 on small b is again R2. So what is the R2 production? A derives A capital A, right? So here, now we can do the reduction. This A can be reduced to capital A, that is A. So how many symbols are in the right hand side? 2 symbols. So you have to cut 2 tops numbers here, and then 0 on A capital A. What is 0 on capital A? It is 2. So write 0, 2. And here we have B dollar. So now see 2 on B. What is 2 on B? 2 on B is S7. So S7 means shift. So it is dollar capital A and B is shifted here. So here we have dollar alone. And this 0 to 7 is pushed inside the stack. And now we have to see 7 on dollar. What is 7 on dollar? That is R3. So R3 means you know the production number is A derives B. So what I can reduce, this B can be now reduced to capital A, right? B's can be reduced to capital A. And if you see in the RHS, we have only one symbol. So you can reduce one entry here. So you'll get 2. 2 on A. What is 2 on A? 2 on capital A is 5. So you have to push it there to 5, and here it is dollar. So now see top of the stack we have 5, and here it is dollar. So 5 on dollar. What is 5 on dollar? It is R1. So what is R1? Yes, derives capital AA. So we can reduce this capital AA to yes. So, and what is the next thing you have to do? Since in the RHS we have 2 symbols, you have to cut the 2 symbols and 0 on this yes. What is 0 on yes? It is 1. So you have to write 0, 1. And here you have dollar, right? And then top of the stack we have 1, and here it is dollar. So 1 on dollar, what is 1 on dollar? It is accept. So we done with it. Accept. So we can, we know that it is a valid string, right? So ABB is a valid input string without any syntactical error, which means parsing is successfully done, which means the input string can be derived from this given context-free grammar. So this is how CLR can be done. Same way we can also use this LALR, and you can also do the parsing. And the conflicts which may arrive here also, sometimes you have reduce conflicts, or shift and reduce conflict, because what is the meaning of it? In the same place you can have reduce as well as shift, or also you have reduce and reduce. So for example, so if you have in the same place, if you have this both entry, it may create a conflict. Otherwise, it will not be a problem. So CLR is the most powerful one, so it will be working good. Sometimes it may have this is the general issues in the bottom-up parser. These are the conflicts which may occur. Hope you have understood this algorithm. So practice well. If you have any doubt, you please look at the video once more, so you will be understanding it very clearly. Thank you more. God bless you.